Hello dear students, hope you all are fine in this pandemic time. Today we are here with the chapter number 2, chemical bonding. And this is the last part of this chapter. So let's get started. A special type of covalent bond is coordinate bond. Covalent bond, coordinate covalent bond or dative bond. The formation of coordinate covalent bond was explained by Sidgwick. Definition: dative bond is a bond formed by sharing of electron pair, but the shared pair is contributed by one atom. Coordinate covalent bond is semipolar bond. Characteristics of dative bond: the atom which contributes the electron pair for sharing is called electron pair donor. The donor atom must have at least one pair of electrons in valence shell, and an atom which accepts electron pair is called electron pair acceptor. It should have vacant orbital in valence shell. Coordinate covalent bond shown by an arrow pointing from donor to acceptor. Properties of compounds with coordinate covalent bond: they are gases or liquids due to weak intermolecular forces. The melting and boiling points of coordinate compounds are higher than covalent compounds, but lower than ionic compounds. Coordinate compounds are soluble in non-polar solvents like benzene and carbon tetrachloride. They are insoluble in polar solvent like water. They are stable as covalent compounds. They undergo molecular reactions which are slow. They exhibit isomerism due to directional nature of bond. Look at the atomic structure of nitrogen. Nitrogen has 5 electrons in the valence shell. When we show the electrons like this, it represents the number of electrons present in the valence shell of the atom. So nitrogen has 5 electrons in the valence shell. In order to satisfy the octet rule, it needs 3 more electrons. So it shares 3 electrons with 3 hydrogen atoms. So now each hydrogen atom has 2 electrons. That is, it has a duplet structure, and the nitrogen atom has 1, 2, 3, 4, 5, 6, 7, 8 electrons. That is, it has the octet structure. So now this is the formula of ammonia, that is NH3. In this case, you will observe that there are 2 types of electrons. These electrons then known as bonding electrons. Bonding electrons or each pair is known as bonding pair. Since these electrons are present between 2 atoms that are bonded to each other, these pair of electrons are also known as bonding pair of electrons. And we can see a pair of electrons is sitting lonely. It is not bonded to any other atom. Such a pair of electron is known as a lone pair of electron. So the electrons that are not bonded between the 2 atoms, such electrons, like in this case, this is known as the lone pair of electrons. So now we look at a type of compound formation in which we need a species which has at least one pair of lone pair of electrons. In this case, ammonia has one lone pair of electrons. So this is one of the species for the requirement of another compound formation. This is a lone pair of electron in ammonia. So we need a species which has at least one lone pair of electrons. Another species that we need is something which is short of one lone pair of electrons. We know a hydrogen atom has one electron. When it loses one electron, it becomes H+. Now, in order to have a duplet structure, it needs 2 electrons. That is, this H+ is short of one lone pair of electrons. So now we have our two species, one which has at least one lone pair of electrons and another which is short of one lone pair of electrons. So now these two can bond, and this is how they bond. The plus charge of hydrogen is taken up by the entire compound. So it becomes positive overall, and this lone pair of electrons is completely shared by nitrogen and hydrogen. Hydrogen atom in this case, hydrogen ion, was short of one lone pair of electron. That is, it has no electron in order to have a duplicate structure. It needs two electrons. So in this case, this lone pair of electron, nitrogen shares this lone pair of electrons completely with hydrogen. So now the nitrogen atom is also stable as it has the octet structure, and this hydrogen is also stable when it shares the two electrons as it has the duplet structure. So this is known as a coordinate bond. And such type of compounds in which one atom completely shares the lone pair of electrons with another atom which is short of one lone pair of electrons is known as a coordinate or a dative compound. So in this case, this bond is a coordinate bond or a dative bond. We can see two types of bonds here. This is the arrow. The bond with an arrow is a dative or a coordinate bond, and a single bond is a covalent bond. Now we know even in covalent bond there is sharing of electrons, and even in coordinate bond there is sharing of electrons. So what is the difference between the covalent and the coordinate bond? In case of covalent bond, there are two electrons, one electron of hydrogen atom and one electron of nitrogen atom. So both the atoms share one electron each, but in case of a coordinate bond, both the electrons, there are two electrons in this coordinate bond and both the electrons belong to nitrogen atom. They are completely shared by hydrogen atom as well, but hydrogen is not providing any electron. Both the electrons are provided by the nitrogen atom. So the difference between the covalent and the coordinate bond is that in covalent bond, the electrons are provided by both the atoms. In the coordinate bond, the electrons are provided by only one atom and shared by both atoms. So this type of a compound has a coordinate bond. This NH4 plus, that is ammonium ion. In water, there are two lone pair of electrons, and another species which is short of one lone pair of electron, that is H plus ion. It is short of two electrons. That means it is short of one lone pair of electrons. Now these two can form a bond, which is formed in this manner. There is one lone pair of electron which is still left, and oxygen shares one lone pair of electron completely with hydrogen. So we get this positive charge is acquired by the total molecule as the overall charge. So this is the formula of H3O+. In this, oxygen atom is the donor as it is completely sharing one lone pair of electrons with hydrogen, and this hydrogen is the acceptor. So the bond between oxygen and hydrogen is coordinate or a dative bond, which is shown by an arrow. So coordinate bond or a dative bond is formed between two atoms such that one pair of electron is completely provided by one atom and it is shared by the two atoms. Difference between ionic and covalent bond. Definition. An ionic bond is a chemical bond between two dissimilar, that is a metal and a non-metal atoms, in which one atom gives up an electron to another. A covalent bond is a chemical bond that involves the sharing of electrons between two similar atoms. Formation. Formed between a metal and non-metal. A covalent bond is formed between two nonmetals. Polarity. Ionic bond is having high polarity, whereas covalent is having low polarity. Shape of molecule. No definite shape, lattice structures. While covalent bond is having definite shape. Examples: sodium chloride and sulfuric acid for ionic bond, methane and hydrochloric acid for covalent bond. Melting point of ionic bonds are very high, whereas low melting point is of covalent bonds. Boiling point. Ionic bonds high boiling point and covalent bond low boiling point. State at room temperature. Ionic bonds are usually solid while covalent bonds are solid, liquid and gas. Ionic bond is having high electrical conductivity while covalent bond is having none. So students, here we have completed chapter number 2. Hope that all the topics are clear to you all. Give me your feedback. We'll meet in the next class with new chapter. Till then, take care, be safe.